Hello, my name is Bruce Reed. I'm an assistant professor in the Department of Biology at the University of Waterloo in Waterloo, Ontario, Canada. We're making this video archive today to document a new technique that we've developed for preparing Drosophila embryos for live imaging analysis. While performing live imaging analysis using Drosophila embryos, we frequently use time-lapse acquisition, and this can last several hours. Therefore, it's important to have a technique in which the embryos are protected from dehydration as well as hypoxia. In addition, we also want to develop a technique that would avoid any compression of the embryo in mounting. What we've come up with is a very simple, cheap, and effective method we call the hanging drop preparation. The hanging drop preparation is suitable for live imaging analysis of embryos using stereomicroscopy or any upright compound microscope. This time-lapse movie shows 8 GFP-expressing embryos prepared using the hanging drop protocol and imaged by time-lapse fluorescence microscopy. This imaging sequence represents over 4 hours of elapsed time. The onset of movement shows that these embryos are in a viable condition. We will now take you through a detailed, step-by-step description of how to perform the hanging drop protocol. Embryos are collected on standard grape juice agar plates using an automated Drosophila egg collector from Flymax Scientific Equipment. The automated collector provides synchronized collections of embryos at a predetermined developmental stage. In preparation for hand decorionation of embryos, a piece of double-sided sticky tape is attached to a microscope slide and the backing of the tape is removed. The hanging drop protocol requires a custom chamber made from a 5 mm thick sheet of polycarbonate plastic. The sheet is cut to the dimensions of a microscope slide and a 3 mm deep depression is made with a rotor. Humidification of the live imaging chamber is achieved using a piece of tissue that is being cut to fit the wall of the chamber and wetted with distilled water. Halocarbon oil is ideal for live imaging decorionated Drosophila embryos because it is gas permeable and optically clear. Mixing halocarbon oil series 700 and series 56 at a 1:1 ratio results in a viscosity that is suitable for working with Drosophila embryos. Embryos can be collected from the grape juice agar plates using either jeweler's forceps or a very fine paintbrush. Embryos stick to each other and to the forceps tips. They are easily gathered in clumps. Clumps of embryos adhering to the forceps tips are gently lowered onto the sticky surface of the tape on the previously prepared decorionation slide. While viewing the embryos through a stereo microscope, gently nudge them or stroke them with the side of the forceps. You must break open the chorion without rupturing the inner vitelline membrane. This requires a steady hand, patience, and some practice. Once the outer chorion has been ruptured, the decorionated embryo tends to adhere to the forceps. Be careful not to allow the decorionated embryo to contact the sticky surface of the tape. It can be very difficult to retrieve it from the tape. Quickly transfer decorionated embryos to the halocarbon oil drops on the cover slip. It's a good idea to keep this nearby. By touching the tip of the forceps to the surface of the halocarbon oil drop, the embryo is dislodged from the forceps into the oil. Transfer of the embryo can be confirmed with the naked eye using a black background and a fiber optic illumination source set at an oblique angle. Before decorionating your next embryo, it's useful to wipe the oil from your forceps. Because of their buoyancy in the halocarbon oil, the decorionated embryos float on the surface of the oil droplet. We can control the position and orientation of the embryos by pushing them to the bottom of the oil droplet and quickly inverting the cover slip. In the hanging drop protocol, we invert the cover slip over the humidified well of the live imaging chamber. When the cover slip is inverted, the embryos will rest against the cover slip's underside. The resting positions of the embryos can be checked under a stereo microscope. If not satisfactory, the procedure can be repeated. Once embryos are in a desired position, the cover slip is secured to the live imaging chamber with tape. The chamber is ventilated by cutting holes in the tape. The embryos are now ready to be imaged.